Hello, folks. So, in this video, I wanted to talk about some of the things that I noticed when it comes to Uptime Kuma. So, this is our Uptime Kuma weather. So, we have two versions. One is a V1, this is a V1, 1.23.1, and this is V2, the newer one. How do you find the difference? I mean, you can only tell the difference by looking at the settings. So you have to go to the settings and check the about, and it will say V2, and this is V1, V123.1, and the front end also shows up, front end version, right? So the other difference visually you can see is basically in 1.23.1, this was actually purple in color maintenance. This is actually grey in color. I think even if you put something in maintenance, it will be grey. I'm not sure though. Yeah, I mean, you'll find a lot of user interface difference here and there. Mainly in terms of performance. I heard that this is faster, V2 is faster. Anyways, so Uptime Kuma, right? Like, I actually checked out some of the features of Uptime Kuma as part of working with it. And one thing that I noticed was, the database that it uses, the schema was not great, right? So basically, if you look at the schema, you can actually go to the source code and check it out. So they basically have unnecessary columns in some of their tables where the columns are not used for all the rows, right? It's basically a lack of normalization. So let me give you an example. Just a minute. I need to pause for a moment. Hello, folks. I'm back. So I'm actually connected to the database of basically the Uptime Kuma. So which is actually a Node.js software. So I've connected to the database. And if you say show tables, you'll notice that there are these many tables. And if you describe, let's say, this table called monitor, you will notice that it has so many fields, and not all the fields are used for all the rows. For example, it has different kinds of monitors. Uptime Kuma, it can actually so Uptime Kuma is used to check the uptime and understand if a service is up or not, and to give alerts if it is down, and to check how much time it is up for, because it's uptime, right? You check the uptime, so that's why the name of Uptime Kuma also. So it checks for services in multiple ways. So it has different ways to connect to services. HTTP, there is what do you say? There is even like custom protocols, like TCP based protocols, like say I think you can do for MySQL and whatnot. So if you look at add monitor, you'll notice so many different types of monitors. There is TCP port, there is SMTP, simple mail transfer protocol. I think SNMP is simple network management protocol, I think, and then there's HTTP based on keyword, like what you can check in HTTP. There is also gRPC, and then there is RabbitMQ, Kafka Producer, PostgreSQL, MySQL, MariaDB, MongoDB, and Redis, and some more things. So the thing is, just a minute. So the thing is, when you create these monitors, when you say add new monitor, the type of the monitor will come up here. So there is an ID, name, if it's active or not, user ID, who created it, and all that, and then interval in which you have to check, do a heartbeat check and all that. URL. So URL is not required for all the things. I mean, okay, in this case it's a network service, and the monitor is only for network services. So it makes sense. It's of a group which is actually just a configuration to group things. Everything else will have some sort of URL or host name or some IP address basically to connect to. So URL is fine maybe. So using domain name you can find out the IP and all. Type, to understand the type, okay. But then the craziest thing comes up later, like these host name, port and all is fine. Keyword. So this thing is actually used only for these monitors which say HTTPS keyword and gRPC keyword. It's basically a case where you hit a HTTP server, you hit a gRPC server which is also HTTP2 based. So you connect to it, and the response you get, it should have a keyword, it should contain a keyword. If that keyword is there, then things are up. If that keyword is not there, then something is down. That monitor is down, at least it's considered down, and something is wrong or something is down, right? Something has an issue, something is problematic. Now this is not used for any other type of monitor, but it's there in the monitors database in the table. And the same is true for, say, things like accepted status codes. This is only true for HTTP related stuff, right? For some reason they put all the monitors in one table, which is not a great thing. So I really don't like it that much in terms of like the normalization part. Maybe this was done to make it simpler, make the model of the whole system simpler. But then, I would have liked it to be normalized. I would have liked it to be kept in separate tables. HTTP monitors, one table. gRPC monitors, one table. And then like say TCP monitors, one table. Like at least to some extent, some grouping to say that hey, I don't want to put all the monitors, all the data in one table, because not all the rows will contain all the columns, right? For example, DNS resolve server comes up only for DNS related stuff. There is one monitor called DNS monitor, right? So that comes up only there, the resolve server. Nothing else has it, right? So the DNS last result, retry interval and whatnot. So too many things are actually used only when it's required. For example, authentication details, it's there in every row. That column has been defined for the whole table and it's there in every row. Even if you don't use an authentication thing, it will just be empty. If you do use it, okay, something will be there. And there are different types of authentication mechanisms, right? There is basic auth, there is MTLS. They support multiple authentication mechanisms. So they have NTLM, they have OAuth 2 also. So they will have columns for everything. And then they'll have MQTT stuff and all. There is one monitor for MQTT. So, and they will have all of this, and none of these will be filled in for the rows which are like say HTTP related or gRPC related and all that. It's just unnecessary amount of columns in one table, right? So there are basically 95 columns, right? So there are basically 95 columns, and I don't know, I mean, it doesn't make sense. So there are other tables also. I haven't checked out much about the other tables, but they have tables like this is some migration related stuff. There is a table for maintenance, and then grouping of monitors, and then monitor notification stuff, and then tagging. And then I think this is also related to maintenance stuff and all. And then finally notification itself. And I think there's one for heartbeat to find out the uptime and stuff, I guess. I still have to understand the other tables. I haven't gone through, but I didn't like the fact that monitor table had so many things where all the monitors are put together and things that are which didn't feel great. I understand it's tricky because depending on it's like an interface. Monitor is like an interface where it inherits. It is you inherit from the monitor class, and you create HTTP monitor, gRPC monitor, and whatnot. There are some fields which are common, like say name and stuff, right? Which group under which group it is and whatnot. But then everything else, like specificity of the monitor, say HTTP, gRPC, Redis, SMTP, DNS, MQTT, everything will have its own specifics. I think probably the issue they might have faced would have been they want to refer to the details of the monitor using a monitor ID. They would have wanted the reference, the foreign key, primary key relationship between, say, for tags, notifications, and whatnot, because they were normalizing that part though. When you normalize and cut out that part, now you can't say your you have one foreign key from one table, another foreign key from another table, one for gRPC monitor, one for HTTP monitor. Maybe that's the reason. I don't know what caused it. I wonder how I would design it if I bring, like, if I uh, build this system from scratch and bring these entities inside a system and then try to understand how to model them and create relationships among them. So for the entity relationship stuff, many to many and all that. And the other thing is, yeah, I mean, the foreign key reference is one thing that I can think of that would have been a problem, because in all these cases they would actually be referring to this monitor, and they'll be referring to the monitor ID primary key as a foreign key in these other tables. If you had multiple monitors, multiple monitor tables, how will you, these are all generic information that can be kept in one table, how will you refer to uh, different monitor tables, monitors from one monitor group, which talks about the grouping? Or you'll have to have different tables for even notifications and maintenance and tags and whatnot, depending on the monitors that you have, how many other monitors you have. So basically, the more number of monitors you have, the more number of tables that will proliferate. And you can't bring in custom monitors probably. So there might be a better way to solve this, but I didn't like this way that much. And looking at the code, it was too basic. One good thing is maybe it's not that basic. Maybe it was built to like to be simple and for someone to be able to understand it. It was built like that probably. I noticed some of the code, it was very straightforward, basic and stuff. But of course, if I write it from scratch, I wonder how I would write it. It's been long since I wrote like backend services and all. I probably did it only for around a year. That's all. In my 8 years of career, I've built microservices backend and stuff only for around 1.5 years. That's all, right? So and I mean, looking at this code, it looks very basic. I probably would write the same basic code, but I have very less experience in terms of like writing backend logic. But looking at it as logic in general, it's okay. It seems okay, right? The only problems that I noticed was error handling and stuff, and what do you say, checks for the columns and stuff. It's tricky. I agree to that because a lot of times they take up creation of a monitor for like you can create a monitor with any fields and anything, and it'll just create it. It'll just have the data. And there's actually APIs around this, like client libraries around this. There's one Python API. Kuma API. It's a Python library. Python library for this Uptime Kuma socket API. It's basically based on socket.io. So this Python library does a lot of actually checking, but the only problem is even this library adds on extra data to the monitors, which is not needed. For example, HTTP monitor, it'll add DNS monitor related stuff and all. And the craziest thing is when you try to edit the monitor, when it gets the monitor from the Uptime Kuma API, it'll check, okay. And if you had created the monitor using a different API, for example, I used a JavaScript client library to create the monitors, and then I used the Python library to edit it, and I couldn't because it gave an error saying that there was a value error because a JSON query monitor, which is basically a HTTP, a monitor against URL which provides a JSON response, and where you can actually run a JSON query against it and then do a check, and that's why it's called JSON query. But this Python library was actually looking for a DNS value against it, and it was like there is no such value, DNS value, so I'll throw an error. That's all, right? I was like, wow. So it would do that, right? So let me show that to you maybe if you want, like so So basically over here, so I can actually create a uptime Kuma temp, right? Okay, that exists already. Temp Kuma temp. Okay. So I ran some stuff yesterday. So I'll just create a uptime Kuma temp Python, right? Right. Here I'll actually put some files. So just a minute. Yeah. I need the Python file, right? And Python file.log. So basically Python, and the name of this thing is this. Let's see if I can put this in. Okay, so I have this now, and then I'll put the log file also. Okay, so I have this. Final thing to do is I basically have a create or update deployments, right? I basically created this Python script. You can actually check it out here. So this Python script I created yesterday, day before yesterday, and I updated it to do the updates also, right? So here what happened is, I think I've been working on this since when, like I think Python to create a deployment rename script. So I think day first itself I had it. So actually see so 995 okay. So okay, so if you see here, I was actually creating two scripts. So one script for deployments, one script for stateful sets. Basically what we were doing was, let me show it to you. Here you'll notice that there's a script called create or update Kubernetes deployment monitors. There's no monitor which is like a Kubernetes deployment and all over here, or Kubernetes stateful set. We basically run a HTTP monitor, specifically HTTP JSON query, and then we run a Prometheus query here, right? And we run a Prometheus query, we check the response of it, and basically the Prometheus Prometheus query language PromQL query, we'll run it using, and basically use the Prometheus API and run a PromQL, get the JSON output, and then run a query against it, and then finally we'll say if a deployment is down or not. Basically this is similar to writing a alert rule in Prometheus using the prompt query language, Prometheus query language PromQL query, and saying when to give an alert. But we wrote this on Uptime because we have it of course on Prometheus. In Uptime, how it helps is basically it'll actually hit it every few seconds, let's say 60 seconds in this case. We'll know the uptime basically. It would have been nicer if Prometheus itself had some way to actually, so Prometheus is also always scraping say Kubernetes metrics and all that, and Prometheus stores the metrics data. So it hits some endpoints, exporters, and then gets the metrics, and then stores the metrics data, and it hits the endpoints every few seconds depending on the scrape interval. So our scrape interval is like by default I think it's 30 seconds or something, but depending on the endpoint and how frequently it gives data, the Prometheus scrape interval can be configured. But if Prometheus is already hitting the endpoints of the exporter to get the data, metrics data, can it also show the uptime, right? Maybe it can have an alive. There is usually an alive, basically, is it up or not, alive metric. If it is 1, it will be like alive. If it's 0, it's not alive. Maybe using that you can find out the uptime, assuming you hit the exporter or the metrics endpoint every few seconds. So with that level of granularity, you can say every 1 minute, let's say you hit it, you will be able to say at a granularity level of 1 minute if a service is up or not, right? And in that case, you'll be able to tell uptime with the level of granularity of 1 minute. So if you have 100 minutes, that is 100 uptime checks, you can actually know for how long it was up. Like in those 100 uptime checks, if it was alive and up for 97 of them, then you can say in the 100 minutes you have 97% uptime, right? So I think it's a better way to try it out, because Prometheus is already getting the metrics, and using Uptime Kuma just for getting uptime in this case seems a bit extra, because Uptime Kuma is hitting Prometheus and getting the data. Prometheus is hitting the exporters or the directly the metrics endpoint of the application, and hitting some exporters or basically some endpoint. It can be the exporters metrics endpoint or it can be the application's metrics endpoint. It is hitting it and getting the data. If Prometheus is already hitting it and getting the data, we can also probably just store in a way the uptime also, like if it is up or not, and then calculate the uptime. The other thing Uptime Kuma helps with is, of course, knowing if something is down or not. Prometheus already helps with that. So we can write alert rules, and we are writing alert rules for that. So in our case, for this particular problem, where we use monitors to actually check if deployments are up and for how long they're up, and for stateful sets, hitting Prometheus and getting the data about stateful sets and checking for how long they're up and if they're up, it's a bit extra. It's like a bit of an over engineering in my view, because there is already Prometheus for your metrics and to even know if something is up or not. And based on that, you can also find out uptime if you have proper scrape intervals and the granularity. On top of it, you're trying to keep uptime and trying to hit Prometheus to get that data and show it. But yeah, I mean, Uptime has its uptime calculation. I need to check it out how they calculate the uptime. In Prometheus, can you do it? I think you can, or you can extend it a bit, or maybe you could say that uptime is that only, but I don't know. I need to go and check it out, but I think even the Prometheus up or down metric can help with this by checking out how many times it was up and how many times it was down, and basically tell how many times the check was done, and then understand the scrape intervals. Let's say if it was 1 minute and there were 100 checks or 1000 checks, and in that 990 times it was up, then you can just say 990 by 1000 percentage, like into 100 percentage, so like kind of like 99% or something, right? You can just say that that's the thing, 99% was the uptime, because with the granularity of 1 minute where things were up. But then of course, if you want exactly the exact uptime, then you'll have to hit every second basically, and every second you have to hit and get the uptime, like get if it is up and running, get if it is up, the service is up, and if it's functioning, and check the status, and then calculate what is the uptime. So hitting every second can be actually pretty heavy on the service. Not too heavy, but still, every second is just a lot of traffic. Every second would mean every minute that is 60 seconds per minute, and that's 3600 per hour, and that's a lot of requests per day per year. But just to be able to find the uptime, I think it's not a problem. You can do it. Every minute once is like okay for just to know, for just knowing the uptime. But that's not what we do here in our uptime. We actually run it for every, let's say, every 60 seconds we run it. So yeah. And what else? So yeah, that's my thought process on like how uptime has its own tricky stuff, like how it has one table for all the monitors, it has too many things, and how we are using it on top of Prometheus, which doesn't make sense. But yeah, I shouldn't lie. I do like that this software is open source and you can read it, and the UI is pretty good, and it works pretty well, not bad. Of course, I can see some cons here, like how it has been built, and the cons of like our usage where we are using it on top of Prometheus, where Prometheus itself can give us the data directly, and probably we can use the same for even the uptime instead of using Uptime Kuma. And yeah, I mean the way Uptime Kuma has been written, and the APIs around it, like the Python API, the library is not great. So let me show it to you. So the error that I got recently, basically I used the um, WebSocket, the socket.io API directly using a JavaScript client, and created some of the monitors. Now those monitors I'm not able to edit it using the Python library. I'll show you the kind of error I get. 1 minute. Okay, so just a minute. Okay, so let me actually run pip env. Just a minute. I actually have to also make some changes in the code. Just a minute. So pip env install. Okay, pip install pip env. Okay. Just a minute. Okay, so this one has pip file says basically it has to be 3.13. Even the log says that only thing. Let me check. I don't want it to be 3.13, so yeah. Let me remove the log file first. So I can actually remove the pip file also. I can just say pip env install, creating a virtual environment, creating a pip file. So if I just do pip env install, nothing should show. So here I'll just say uptime Kuma API. This should install the stuff, and then I want to actually change the file, because my Python code requires an extra thing called JSON path operator, which is not accepted in the thing, in the Python library. So I need to make a change. env shell, or just say install for now. So if if I look at the shell, I think it will show you from where it got it. It's basically using this, right? Just a minute. So I can go here and get the libraries and then site packages and Kuma. So here the .api file, API.py file, I need to check it out. I'll use the Vim and I'll look for JSON path. So here I'll just say JSON path operator, right? JSON path operator. So just say JSON path operator. I need to create a what do you say? This is just a doc, so I don't need it. JSON path operator, and JSON path operator is over here also. Okay, so this is clear now. This is just some documentation, so it's fine. So now I'm gonna actually run the thing, right? Let me use a tmux just in case. Should I? Okay. So pip env Python Okay. Let me just say pip env shell Python is 3.9. Okay. Python and then create this, right? I'll try to run this and I don't think it will create any monitors because I already have a lot of monitors. Let me see how this goes. This is the one I'm using. I think it's taking a lot of time to just log in. So it's processing all the Prometheus URLs to get the deployment related information, and it says what are the existing deployment monitors to update and then new deployment monitors to add. Now the edit will fail if you notice actually. It'll say that there is a error in the added monitors 0. And it tries to edit, it should give an error. It's trying to log in, so there are like 3 logins, so it should give an error. So here you can actually see the error. So basically any monitor that I created using the Uptime Kuma Python API, it's going fine, right? So you'll notice that there are no issues. For example, this one is called CodeNS. This is something that I created using this Python thing, so it's fine. These are also fine. Now the first time it encounters a monitor that was created using some other API, not the Python library, and it was created using a JavaScript library that I created. The first error it says is, so this is actually a JSON query type, but it says unknown DNS result type, value DNS result type, that's all. So basically I think this comes up in, let me check it out. So looks like doesn't give me the exact error. Let me see. This is the okay, yeah, cool. So this is the code, and the actual value of DNS resolve type is none. This is none because I didn't require a DNS resolve type, and hence I didn't put that data in the Uptime Kuma. So if you actually go into the Uptime Kuma and find this out, like let's say 195, select star from monitor where ID is equal to 195, and you check it out, you'll notice that the DNS resolve type is null over here, right? Now if you look at the other ones, so 1 minute. If you look at the other ones, for example, the one where it didn't give this error, say 525, you'll notice that there are so many things that it doesn't require but it has. For example, both are JSON queries, but then here you'll notice that it has, okay, status codes is fine. It has a DNS resolve type A, which is not required. DNS resolve server, which is not required. This is all created by the Python library, right? So this was created very recently using the Python library, and it put in all this data, right? And then SNMP version 2C something, it's not necessary basically. So here if you see, okay, this is still the same, I think. Maybe I think the server itself did this, but then I didn't put any data for DNS resolve type or DNS resolve server. So for this reason, the Python library just errors out. It says, no, it won't work, right? So it's crazy. So then I had to actually rewrite my Python code, the Python library code that I created based on the Python library. I wrote a script in JavaScript based on the like knowledge that I had from creating a JavaScript based library for Uptime Kuma, and I rewrote this code because the edit was not working out. Add did work, but edit didn't work out. Now I have one more code for stateful set, which I need to rewrite in JavaScript. I could give it to AI, but I just wrote it myself because I also noticed a lot of problems in the code. So yeah, I mean, it was very tricky. So I was like, boy, I need to rewrite because the Python code was not working because of this reason. I could go ahead and change all the monitors and say, have this DNS resolve type and DNS, resolve server. I think that is the only thing that I would require, because looking at the checking that they have, they do all these checks, and then they do the resolve type check, and then Kafka producer check. That's all, right? Now mechanism, they should have a value, so it should be one of these. Wow, okay. So I think everything was fine in my case except for this one and this one. Let me see this Kafka producer SSL options. Where is it? Kafka producer topic SSL, okay, 0. Only if the type is Kafka producer, okay. So great, at least it didn't always look for it. This should have been checked only if the type is DNS monitor actually. For some reason it has been checked for everything, and same, this has to be checked only for HTTP related stuff. So it's weird, and I don't know, check argument conditions, I think this is a check it does based on this, like in this function, based on these things, I think. So yeah. Anyways, so I was like, I'm just gonna go ahead and just change this. I'm not gonna use the Python code, I'm gonna rewrite. I decided to spend more time on it, and waste time. Not exactly waste time, it was good to rewrite the code. And I also got to actually write better code because it was hard to understand some of the code here. Of course, it's not impossible. I was able to understand it was not that bad, but it was nicer to actually read the code in a bit in a better way. There are more things that I can do. I'll probably create a separate video for that. Um, but yeah, that's all I wanted to talk about. Uptime Kuma and how we are using Uptime Kuma on top of the Prometheus API, using the PromQL query and running them, and then finding out the uptime in Uptime Kuma, and also checking out if our service is up or not. Though we can just use Prometheus itself, we already do use it. Find out if our service, if our pod deployment stateful set is already up and ready. Um, cool. So yeah, that's all. That's all I had for this video. That's all. I'll see you in the next one. Bye bye.